You know, we're in this incredible race right now to build AI that doesn't just follow orders, but that actually learns on its own. And the secret, it turns out, isn't just about building a bigger AI brain. Nope. The real breakthrough is all about how we teach them, how we give them their notes for the day. This is a fundamental shift in how AI is getting smarter. Which really brings us to the central question, right? How do these AI agents actually learn out there in the wild? I mean, it's not just about their initial training anymore. The real magic, the part that matters, is when they have to adapt to new tasks, new information, moment by moment. And the key to all this on-the-job learning is a concept called context adaptation. Now, instead of these super costly, time-consuming retraining sessions, you just update the AI's instructions. You update its context. The analogy from the research here is just perfect. Imagine you have this brilliant assistant who has absolutely no long-term memory. So before every single job, you have to hand them a fresh set of notes just to get them up to speed. But here's the thing. There's a huge problem with our brilliant amnesiac assistant. The way we're currently giving it notes, it's deeply flawed. And when this method fails, the results can be, well, pretty catastrophic. Let's dig into what's going wrong. So the research paper points to two critical ways this whole thing breaks down. First up, you've got something called brevity bias. This is where the AI, in an attempt to be efficient, just keeps shortening its own instructions until they're totally useless. It's like turning a detailed step-by-step recipe into just make dinner. Then you have an even more dramatic problem, context collapse. This is where, after learning a ton of valuable stuff, the AI just gives up. It throws away all its detailed notes and replaces them with a short, useless summary like, did stuff. All that hard-won experience, poof, gone. So what does this failure actually look like in practice? Well, the researchers caught it red-handed in their experiments, and honestly, the data is pretty shocking. Okay, so check this out. At its peak performance, an AI agent had built up this incredibly rich, detailed set of instructions. We are talking over 18,000 tokens, and you can think of tokens as little pieces of words of pure, hard-won knowledge. It had detailed strategies, lessons learned. It was performing incredibly well. And then, in one single step, this happened. Complete context collapse. All of that knowledge just vanished, crushed down into a measly 122 tokens. The AI basically wiped its own memory. And its performance didn't just drop a little. It plummeted to a level below what it could do with no special instructions at all. It's clear this way of learning is fundamentally broken. So how in the world do you fix an AI that keeps erasing its own brain? The researchers came up with a completely new framework, and it's called Agentic Context Engineering, or ACE for short. And this, my friends, is where things get really, really clever. The core idea behind ACE is a total shift in thinking. As the researchers themselves put it, the goal is no longer about making a concise summary. It's about building a comprehensive, evolving playbook, a living, breathing document that gets richer and more detailed over time. Just think about it like a football team's playbook, right? A team doesn't just throw out the entire book after one game. Of course not. The coaches review the tape, they see what worked, what didn't, and they add new plays or they tweak the old ones. That is exactly what ACE does for an AI agent. Okay, a self-updating playbook is a fantastic idea, but how does it actually work? I mean, how does an AI review its own game tape and then add new plays to the book? ACE uses this brilliant three-part agentic loop. First, you have the generator agent. It's like the player on the field, trying to complete a task using the current playbook. Then, the reflector agent steps in. This is the coach, reviewing the game tape of the generator's performance. And finally, you have the curator agent, the team strategist. It takes all the insights from the reflector and decides exactly what new plays need to be added to the playbook. And this loop is the absolute key to solving our original problems. See, instead of rewriting the whole playbook, which is what risks that dreaded context collapse, ACE only makes small, incremental updates. It adds or refines specific plays. This preserves all that valuable knowledge and allows the playbook to grow in a structured way, which also prevents that brevity bias we saw earlier. Okay, so the theory is sound, it makes a lot of sense, but does it actually work in the real world? Well, the results are in, and let me tell you, they show that ACE isn't just a little bit better, it's smarter, it's faster, and it's cheaper. So, on a really challenging AI benchmark called AppWorld, the previous best methods were averaging under 47% accuracy. With ACE, that number jumps to nearly 60%. That is a massive leap in performance. It just proves this whole playbook method is way more effective. But here's the most impressive finding in the entire paper. It's not just about getting higher scores. It's about who is getting those scores. With this new learning technique, a smaller open-source model was able to match and, in some cases, even surpass a top-tier agent from IBM and Google that was powered by the massive GPT-4. I mean, think about that for a second. Smarter instructions can completely level the playing field, allowing these smaller models to punch way, way above their weight class. But wait, it gets even better. ACE doesn't just produce smarter agents, it builds them more efficiently. It's not just about the final score, it's about how quickly and how cheaply you can get there. Because ACE is just making these small, smart updates instead of huge rewrites, the time it takes to learn from a new experience, what they call adaptation latency, is slashed by nearly 87%. It just learns faster. It's that simple. And this efficiency also means huge cost savings. The AI needs 75% fewer attempts, or rollouts, to get its playbook just right. That translates directly to less computation, less time, and lower costs to get to peak performance. So what does all this mean? Why does a smarter way to update an AI's instructions matter so much? Well, this research really feels like it's pointing us toward the future of AI systems. What ACE gives us is a roadmap for a new kind of AI, truly autonomous agents that learn from every single experience without needing that constant, expensive retraining. And because the playbook is just a text file, we can literally open it up and read it to understand what the AI has learned. This is a scalable, efficient, and frankly, a huge step towards AI that genuinely improves itself on the job. And that leaves us with a final, pretty fascinating question. Forgetting has been one of the biggest roadblocks for AI agents for a long time. But if we can solve that, if we can give our AI a perfect evolving memory of every success and every failure, what becomes possible then?